Let's do some whiteboarding here. If I take a prompt, um, the lion, cat, tiger, road has plane flew overhead. So this I want to divide it into tokens. I'm trying to show you a whiteboarding demo to show how this will all happen when we try to enter a prompt and see where and all it goes. Step 2, we learned about tokenization, how these sentences will be divided into different words or tokens. Once tokenization is done, the next step would be trying to do a embedding lookup. So all these words, the, lion, cat, tiger, these are all given some vector embedding. Specifically, the words lion, cat, tiger, and the plane, these are all, let's take these four words for example, ignore the others, trying to understand how the context, as a human we really understand what is the context. We went over in the module 2 starting. So if without context, AI don't understand. Even as a human we can relate to context, but how machines can relate to context, that's what I'm trying to explain step by step, how these are all look like in terms of machine, right? So number 4, contextualization. These vectors, when I say vector, is nothing but all these words represent as numbers. As we discussed long time back, machine understands only numbers. How it stores, it's all zero and ones, as you know. But if we want to store it as number, each token, so how these will be numbers look like, on with respect to context in terms of machine, these vectors, like example, if we take lion, cat, tiger, and plane, these will be adjusted based on their surrounding, like type of the meaning. Like example, lion and tiger, they're all closely related, they're all like wild animals, right? Cat might be a little different, but still a family of lion and tiger. Plane is completely different word. It'll be like transportation or something in motion. So that's the context we are talking about. Then further, if you want to see, it will do a semantic clustering. Semantic is nothing but something, all the related can be grouped together to form something like a cluster, right? Then this structure, whatever we are forming, like different clusters, it will be seen as, it'll be used further for understanding what is trying to say, the meaning of it, and try to predict what could be the next immediate word based on the weightage. See that this, if I say lion, tiger, the next word, if I want to guess, you can say cheetah, because it's the closest one. It's all wild animals. That's how the next word will be predicted based on the priorities and, um, something called engrams. I don't want to explain today, but based on the predictive algorithms, based on this clustering, it will be able to find next word and try to answer, um, from the LLM, right? If I want to further go, if I want to take these four words and try to see how we can put it as a vector or a number in two-dimensional view, so these, all these words tokens will be converted to number, and they will be all stored as a table. Imagine there is a table with two dimension. Let me show you, by putting up a table and giving some approximated number to show you how they are all related. So in this two-dimensional view, if I take these four words, this is how the numbers will be allocated based on, um, the type of the word and context behind it, right? See, when you see here lion and tiger, because these are domestic, 0.80 and 0.85 is almost close by. In the other dimension, zero point 0.9 and 0.95, again close by. And the cat is almost close to lion tiger, however, the plane is completely in a different dimension or different direction. So if I want to plot this in a graphical view, in a two dimension, say x axis and y axis, if I want to represent all these words based on this value weightage, this is how they look like. See, plane is completely somewhere else, and all these forming like a category or a cluster. That's the semantic clustering. See, once we come up with all this graph and picturization, then LLM or large language model, the GPTs, will be able to understand, contextualize, understand the relation between them by doing a semantic search, and it will be able to get you the things faster. That's how this background of GPTs and LLMs, based on the computational power, they will be able to give us the answer, predict the next answer, generate new things, right? So if I want to show you this demo in a real time, if I take some long, large things, set of words, see, this is how this I was trying to plot it based on the position, how we are trying to put the each words. Let me take you the embedding structure. This one I wanted to show you. If I take 200 dimensions, it's a multi-dimension vectors, how they will look like. See, it's all words. If I go on them, these are all different words, right? So if I want to take only two components, it's all in two dimensional, how they are all seen. If I want to search some word, say example, let's take plane. All these are related. Let's take another example, transport. See, all these are related. Transport, transported, transportation. Let's take three components and let's search something here. Shaped. So if I want to see neighbors, 100 words, all these triangle, rectangle, these are all related, and see this vector score added to each one. Now you understand how AI or machine from the backend large language model, they all store these words, and how quickly they will be able to relate, understand the context, and understand the semantic clustering, and then it'll be able to predict what is the next word or what we are trying to get the answer.